Prime and composite. Prime numbers are divisible by 1 and itself. And so composite numbers are going to be divisible by numbers or factors. Now, composite numbers also do not have a remainder when you divide them. So let's look at the first example. We can kind of go over this some more. So you own a lawn mowing business and have 4 employees. Is 4 a prime or composite number? Well, let's just go ahead and draw 4 stick figures, right, to represent employees. Obviously the worst drawing, but that's to indicate that we just have 4 employees, right? And so prime numbers is meaning that we cannot divide this into equal smaller groups, right? Whereas composite numbers is we could actually divide this into smaller equal groups. So 4, right, like essentially you could have 2 teams of 2 here. And so if you can break it down into a smaller group with equal amount in each one, right, then it'd be considered a composite number. But if we couldn't do this, then it would be considered a prime number. So let's go ahead and look at the next example. So in your classes at BBCC, there are 7 students in one class. Is the number 7 a prime or composite number? So let's just go ahead and just do dots to represent, right, each student. Now we have 7 dots, and now we're going to see, can we divide this into equal groups? Well, if we did 2, notice that we only have 1 here. So that's not going to work. So it couldn't be broken down that way. Let's try 3 now. Well, 3 also doesn't work, right? Because we still have this 1. Right, we can do 2 groups of 3, but only have 1 instead of 3 in the last one. So that doesn't work. Let's try 4. Well, if we do 4, well, that's incomplete, right? Because we need to have another dot in order to complete that. So we can say that this number then is a prime number, because we can't break it down any further, like, right? So let's go over some other just common prime numbers, right? We're going to go over, we have 2, 3, 5, 7, 11, 13, 17, 19, 23, and 31. So those are some common prime numbers, and that's up to 31, right? And if we look at all those numbers in between from 2 to 31. And so when dividing numbers, it's important to remember that the number 1 is not a prime number or a composite number. So we did leave out the 1 in the prime numbers, and that's why it's not either. Now let's go ahead and look at the next example. Example 3. Is 43 a prime or composite number? So another way, right, instead of doing what we did by circling, and putting dots in to see if we can make equal amounts, is we can just go ahead and start dividing, kind of look. So 43, if we were to divide it by 2, well, 2 can go into 4 2 times. We subtract, we get 0, bring down the 3. 2 can go into 3 1 times, so that's 2, we get 1. So we're not supposed to have a remainder or a decimal, so it can't be broken down into like 2 groups equally. Let's try 3 now. Can 43 be divided into 3 equal groups is what we're saying. Well, 3 can go into 4 1 time. We subtract, we get 1, bring down the 13. Well, 3 can go into 13 only 4 times, but there's going to be a remainder, right? Because that's 12. So this can't be done. We could try 4, but let's see. Well, 4 can go into 4 1 time. We subtract, we get 0, bring down the 3. 4 can go into 3 how many times? Well, 0. So we're going to have a remainder. So we don't even have to continue on. We can try 5, but we know 5 times 8 is 40, right? So if we were to go 43, we were to have 5. Well, 5 can go not into 40, cannot. Now, 5 can't go into 4, but it can go into 43 8 times. We subtract, we get a remainder. So that's not going to work. Now, we can try 6. Now, notice that we have 5 and 8. So the last kind of numbers, let's try. Well, 6. 43, well, 6 can go into, not 4, but it can go into 43 7 times, because that's 42. So we'll get a remainder, so that doesn't work. Now, we have, essentially, because of the way we've done our numbers, right, we've done 2 and 21, we had 3 and 14, 4 would have been for like 4 and 10, and then something else. We did 5 and 8, and we did 6 and 7. So by looking at the numbers, we started out with smaller numbers, and then you got this larger number. So we've actually looked at all the numbers kind of in between, right, 2 and 43, and we found that there's no number that can go into 43 an even amount of time. So we can't break this into smaller groups, essentially. So we would say that this is a prime number. Now let's go ahead and do the last example. So example 4, is 93 a prime or composite number? So let's go ahead and look. So 93, well, we know it can't be broken down actually by 2 because it's not an even number. Anytime you have 2 and you go divide it into something, it needs to be even in order for it to come out to a number on the top where it's just a whole number. So let's go ahead and try 3. So 3 can go into 9 3 times. We subtract, we get 0, bring down the 3. Well, 3 can go to 3 1 times. Well, we found that this 93 could be broken down into 3 groups of 31 or 31 groups of 3, right? It could be either one. But the point of that is to say that this is a composite number. We can break down this number into equal groups, essentially. So that would be our solution.